Hello students, let's explore the second episode of chapter Light, Reflection and Refraction. Hello students, so in episode 1 we have got one formula here. From that formula we will start our episode 2. That formula was focal length f was equal to radius of curvature divided by 2. That means we can say focal length is half of radius of curvature. So using this one we can solve one question here. If the radius of curvature of a spherical mirror is 20 centimeter, what is the so what will be the solution here? We have to, it is sure that we have to use the formula focal length is equal to half of radius of curvature. Okay, so what is the given part here? We can do directly here. Can you find out? So f, we have to find out radius of curvature is given how much? 20 centimeter. So therefore f is equal to 20 by 2 equal to 10 centimeter. So focal length of the spherical mirror is how much? 10 centimeter. Okay. We will start our next topic, that is the image formation by concave mirror when the object is placed in a different position. So first what we will understand, what we will revise once again, that this is concave mirror, this is principal axis, then after this point the center of spherical mirror is pole, and then after center of the spherical mirror is called as the center of curvature, then after it is the principal focus. Okay, so it is the middle point of the concave mirror which has been cut from a spherical mirror, and this one is the center of the spherical mirror, that is C. Okay, so let's have our next topic, that is the image formation by concave mirror when the object is placed at different position. Okay, so we will start image formation by concave mirror for different position of the object. So using the rules, whatever we have seen in the episode 1, the rules for making the image in a concave mirror. So using that we will start the diagrams here, where will be the object and where will be the image formed in a concave mirror. So first one, the object is at infinity. Where is the position of the object? At infinity. So if I draw here one concave mirror, this is concave mirror, it is principal axis, this is pole, this one is principal focus, and this one is the center of curvature. Okay, so now we don't know the exact location of the object which is represented by infinity. Okay, so from the object, from any side in the infinity part, the ray will be, light rays will come parallel to the principal axis. Okay, parallel to the principal axis. And we know the rule that if it comes parallel to the principal axis, then after reflection, where it will be moving from, it will pass through the principal focus. This point is principal focus. Okay, so if I take another ray, another light ray that is coming from the object, so again it is also parallel to the principal axis. So again this light after reflection, it will be passing through the principal focus. Okay, so we need the definition of image now. So what image definition tells that any point where two reflected rays meets, that forms the image. So here also, after two reflected rays has passed over, they are intersected in one point. That is F. That means principal focus. So first thing that we need to know the position. Where is the position of the image? So position of the image is at F. Okay. Next one, we need to know about the size of the image. So if you see here, what will be the size of the image? It is crossing over, the reflected rays are crossing over a single point. So we can say that the size of the image is a point size. Point size, or we can say highly diminished. Highly diminished. So this word is used when the object is much more smaller than expected. Okay, it's highly diminished, little bit bigger than the point size. It can be said as diminished. That means smaller than the object. We can use the word in place of smaller, we can use diminished, and then after more than small, it is called as the highly diminished. Okay, next we need to know the nature of the image. Okay, so when we have discussed about different types of images, so that time we have got real and virtual image. Okay, so real image, where it was formed, so it was formed by the concave mirror. So what was the meaning of real image? So the real image can be obtained on a screen, and the virtual image can be obtained on a mirror or on a lens. Okay, it cannot be obtained on a screen. So this one we have obtained on a screen. So reflected rays are focused in one point, principal focus, and we can write here the nature is, what we can write, the nature real and inverted, opposite of the mirror, opposite of the object, that is inverted. Okay, next we will see the object at beyond C. Where is the object now? It is beyond C. Okay, so if I draw a concave mirror here, this one is principal axis, this one is pole, this one is principal focus, and this one is the center of curvature. Okay, so now the object, if I draw here A, B, so you can use the pencil and scale to make the drawing, and if you know the exact, if you do practice nicely, so you can be able to draw the exact image position. Okay, so now first rule tells that the light rays will be going parallel to the principal axis. Okay, so then after going through the principal axis, parallel to the principal axis, it will be reflected back from the point that is principal focus. Okay, next one, if I draw from here, what is the next rule? That will be, it will be the light rays will be going through the center of curvature, and if it goes from here, so after reflection it will come back on the same point, that is center of curvature. Okay, so now where the two reflected rays are meeting, that will form as the image. So image is formed where? This is the image. Okay, and this can be named as A dash and B dash. Object was AB and the image is A dash B dash. So here again, if I see the position will be, where will be the position of the image? So between C and F. And what will be the size size is generally smaller than, if you see the size of the image, it is smaller than the object. So small size we can write diminished. Okay, next nature, it will be again real and inverted. It is just inverted as the object is. Okay, so real and inverted. So these are the two images formed by a concave mirror. So next, where is the object at C? Okay, so again I will draw a concave mirror, a little bit curve, and then after principal axis, use scale pencil and try to locate the points properly. Okay, so as you know already that principal focus is half of the center of curvature, so it will have the equal distance CF and FP. Okay, then after object is here, that is AB. Where is the object? At C, that means center of curvature. So first light rays will go parallel with the principal axis. It will go parallel, and then after reflection it will pass through the principal focus. And another one, next rule, what is the nearby point in front of the object? That is F. So we can cross the line from here, or light rays from here, and then after where the light rays will meet after reflection, it will be parallel to the principal axis. Okay, so here the light will pass through. So here is the intersection point between the reflected rays. So this one will give us the image. Okay, this is the image. So image is, where is the image? Image position is at F. Oh, sorry, at C. If I tell the position here, so if you see in the diagram, the position is, where is the position of the image? It is same as the object. Okay, so position of the object is, image is at C. So if you see the size of the image, it is same as the object, so it will be same size. Okay, next if I talk about the nature of the image, it will be again real and inverted. Okay, I have written in short form, I have written already. Next, the object is at, where is the object? Is at between C and F. Okay, so again I am drawing the concave mirror. You can draw the concave mirror with free hand. Okay, so this point is pole, this one is principal focus, this one is the center of curvature. Okay, same, you have to remember the scaling. Okay, it should be in the same distance with the CF and FP should be in the same distance. Okay, and you can draw with a free hand this concave mirror, it should be curved. Okay, so between C and F, so this one is object here between C and F. So first rule tells that it will go parallel to the principal axis, and then after it will cross over the principal focus. Next again we can draw the another light rays, that is the point in front of the object, that is this one, principal focus. So if I draw from here, so our reflected light will be parallel to the principal axis. Okay, so if you see here, this is the point where the image is formed. So the image is formed, where is the image position? It is beyond the C. Okay, try to use the scale. Okay, it will be exact one. So position, it is beyond C. Okay, and when we talk about the size, if you see the size of the image, it is more than that of the object. So here we can write the name of the image, A dash B dash. Okay, so size will be more than the object, so it can be written as enlarged. Okay, next if I talk about the nature, nature is again real and inverted. Okay, next number 5, that is the object is at F now. Okay, so if I draw again the concave mirror, principal focus, then after center of curvature. So where is the object now? It is at F. So it is A and B. Object name is AB. Okay, so now first rule, what it tells, that it will go parallel to the principal axis, and then after reflection it will go through the principal focus. Okay, so next light rays, what is the point in front of the object here? Now it is the point P. Okay, so now here the light rays will fall in pole. Okay, and what the rule tells, that it will go making an equal angle with I, and this one is R. The angle made by the incident light rays, okay, whatever angle it will be making here, that will be same as the reflected light rays, that is R. Okay, so if you see the light rays, it is going a little bit parallel. Okay, so that means they will meet at some place. Okay, and that some place is infinity. So if I talk about the position of the image, that will be at infinity. Okay, then after, if I talk about the size, the object which is at the infinity they will meet, that will be highly enlarged one, highly bigger. Okay, and then after the position, nature will be real and inverted. Okay, so sixth one, where the object is now, it is between pole and principal focus, P and F. So if I draw here concave mirror, this one is pole, this one is principal axis, it is principal focus, and this one is the center of curvature. Always remember to scale nicely the points, principal focus, center of curvature. Okay, they should be in the equal distance from the pole, that is FP will be equal to CF. Okay, so where the object is now is between P and F. So in between P and F, wherever anywhere you can locate the object position. So it is A and B. So here, what is the nearby point in front of the object? It is P. So one line will be going through here. Okay, and then after reflection, it will be going from here. Okay, so if I take the another line, that is the center of curvature, because nothing point is present here. So what I will do, if I draw here parallelly, so it will be intersecting the object, the reflected light rays. So I cannot draw here. So one thing I can draw here, that is from the center of curvature. Okay, the light rays is coming from the center of curvature, and it is going again from the center of curvature. Okay, so if you see the two lines here, two reflected lights, so it will never meet each other. So we have to meet each other so that our image will be formed. Okay, because image definitions always tells that two reflected light rays should be meet at a point or intersect at a point. Okay, so they will not be intersecting each other, so our image will also be not formed. Okay, so what we will do, we will stretch this C. Okay, and then after this line, this reflected light, and then after we will show the image behind the mirror. Okay, so this one is A dash and B dash. Okay, so this is the procedure when the object is at P and F, in between P and F. So they should meet each other. That's why we have drawn the I have drawn the light rays behind the mirror. Okay, after reflection, they should be meeting, or they appear to meet behind the mirror. Okay, so if I talk here about the position, so position where the object image is now, behind the mirror. And where is the what is the size? Size is, it is bigger than the object, so it will be enlarged. Okay, and now what will be the nature now? So nature, if you see here, it is virtual. Okay, virtual and erect. So it has not been formed, our image has not formed in anywhere on the screen. If I place here screen, so there should be the image formed everywhere. Wherever we have drawn earlier, the image was formed on an screen. After reflection, they were meeting at a point, and then after we have the image. But here the image is not formed on an screen. Okay, they are straightly behind the mirror. Okay, as we see in our mirror, the faces that is behind the mirror, so that is the virtual image characteristics. Okay, so our nature becomes virtual and erect now. Okay, only one point where object is at between P and F, the image will be virtual, and other places wherever the object will be, there will be a real and inverted image. Okay, so I hope you have understand the image formation by concave mirror. So this much for episode 2. We will be looking after the image formation by convex mirror also on the next episode, and much more topics will be discussed there in the next episode. Thank you and take care.